This video is about organic compounds. Organic compounds are the compounds based off of carbon. Carbon is the element that has a very unique properties. It is one of the most important elements in the periodic table, and there is a whole chemistry section, um, dedicated to just carbon compounds. That's called organic chemistry. And why we have organic compounds so important, because most of the living organisms are carbon-based compounds. So what we eat, what we are made of, uh, and when we say living organisms, it means humans, animals, plants, everybody is part of it. So organic compound are the compounds of carbon. So by definition, they are carbon-based compounds. Uh, that doesn't mean that if you have maybe NaHCO3, so you have carbon in it. So you cannot say this is an organic compound because it has carbon in it. This compound has to be basically carbon chain compounds. The base of the main element should be the carbon. Okay, so it contains carbon and hydrogen. These are the most important ingredients of the organic compounds. Okay, let me see. Carbon and hydrogen only. Examples are propane, butane, hexane, heptane, octane. These are the chain of organic compounds that we need to know about. So by definition, organic compounds are the carbon-based compounds. We call them hydrocarbons. And Examples are propane. Now, what do you mean by propane? Propane is C3H8 kind of compound. Butane is C4H10 kind of compound. So basically, they're made of carbon, 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 carbon. So carbon has a very unique property of making chain of compounds. It makes a chain, like one carbon is bonded to another carbon, is bonded to another carbon, and it can just go on and on. Okay. So there are some other organic compounds that contains carbon, hydrogen, and some other elements as well. So if there is carbon-based compound, but it has OH in it, it becomes alcohol. If it has NH3 in it, it becomes amine. So there's a possibility that it has other elements attached to it, and it will still be organic compound. But the basic organic compounds are the compounds that has mainly carbon and hydrogen in them. In this unit, we will only learn about the human uses of organic compounds. So organic compounds are, as I said, basically used for plants, animals, and humans. So they have pharmaceutical uses. So the aspirin that we eat, the vitamins, the insulin, it all has organic compounds in it. So these are all human uses. We use them in industry as fuels. Okay, we use them as polymers, natural polymers and synthetic polymers. This question is going to be on your test. That which are the synthetic polymers? Like nylon is something that is man-made. Synthetic means that we made it. Okay, natural means that this is how it exists in nature. We did not make the DNA. We did not make the protein. We were born with it. Okay, so this is natural polymers. Polymer means long chain compound. Okay, first of all, that is a definition of polymer, that these are long chain compounds. Synthetic means man-made polymers. So plastics and nylon are man-made polymers, and DNA and proteins are natural examples of polymers. So once again, we need to understand the definition of organic compounds. These are carbon-based compounds. The main element is going to be carbon and hydrogen, although this is possible to have other elements attached to them, and because of that, they will be given different names. And these are the human uses of organic compounds: pharmaceutical uses, industrial uses, and polymers. Let's talk about one series of organic compounds that are called alkanes. So alkanes are the hydrocarbons that are saturated. Saturated means they have all single bonds. Okay, only single bonds. No double bonds present in them. They're called saturated hydrocarbons. Each carbon has 4 single bonds. Each hydrogen has 1 single bond. For what it means is that we have learned the dot diagram. So carbon has 4 valence electrons. So carbon will make 4 bonds with hydrogen. Okay, this is the basic unit of organic compounds. That's called methane. So methane is CH4. Again, you have 4 carbon atoms. I'm sorry, 1 carbon atom and 4 hydrogen atoms. So after methane comes the ethane. Ethane means I'm going to take 1 carbon atom off, hydrogen off, and put a carbon in there. Now this carbon again is going to make 4 bonds, 1, 2, 3, 4. So it has 4 hydrogens around it. So now this is a formula of ethane. It is C2H6. Now if I want to make propane, propane means 3 carbon atoms. So I say 1, 2, 3 carbon atoms. And then I want to make sure that each carbon atom has 4 bonds around it. Okay, 1, 2, 3, 4, 1, 2, 3, 4. So each carbon atom has 4 bonds around it. Okay, these are called C3, and it is going to be how much? H8. 3, 6, and 8. So C3H8. Okay, this is how you will learn the chain of organic compounds. All you're doing is, like for butane, butane means 4 carbon atoms. So 1, 2, 3, 4 carbon atoms. And then just make sure that every carbon atom has 4 bonds around it. Okay, and all of those are going to be hydrogen. So that is butane. So you don't have to memorize it. Okay, that is the beauty of organic chemistry, that you don't have to memorize it. So let's start with CH4. That is the basic organic compound, methane. And then I'm going to add CH2. Okay, add CH2 to carry on with the chain. So if I add a CH2, it becomes C2H6. Then I add another CH2, it becomes C3H8. Another CH2. Okay, I keep doing it, and it gives me, okay, so I keep doing this. So it's methane. You have to memorize the first 4: methane, ethane, propane, butane. From here on, it goes by the number of carbon atoms. So 5 means pentane. Okay, then 6 means hexane, 7 means heptane. So you understand they all end with ane because we are learning about alkanes. So alkanes means they're all single bonds. Okay, no double bond. They're all single bonds, and they all end up with ane. They are saturated hydrocarbons. If I show you all this for taking notes, so methane, ethane, propane, butane, hexane, heptane, octane, none, decane. So this is, you need to memorize the first 4: methane, ethane, propane, butane. Okay, and you just add CH2, and this is the general formula. It is CnH2n plus 2. This is the general formula of alkanes. Okay, how does this work? So if I want to find out, if I say n equals to 2, so I will say C2 H2 times 2 plus 2. So C2 H4, 2 times 2 is 4, plus 2, H6. Okay, that's C2H6. If I want to find out for 3 carbon atoms, so C3H2 times 3 plus 2, so it is going to be C3H8. Alright, so this is a general formula to calculate alkanes. Alright, that's all you need to know about alkanes. There are hydrocarbons that are saturated, all single bonds. Each carbon is going to make 4 single bonds around it. Prefix tells you the number of carbon atoms, and the suffix is going to be the ane. And you have to memorize the name of these all chains: methane, ethane, propane, butane, hexane, heptane, octane, none, decane. So here is a methane. It is CH4. So 1 carbon with 4 hydrogen atoms around it. Okay, ethane is C2H6. So you have carbon and carbon, C2, and of course you have hydrogens around it. That makes it H6. So it's pretty simple structural formulas. Propane is C3H8. So you have 1, 2, 3, and then you have all hydrogens around it. It's C4H10, 4, and then you have all hydrogens around it. I'm leaving it blank, but you need to put hydrogens around it. You cannot leave it blank. Okay, there are all hydrogens around it. So I want you to go ahead and complete this chain of organic compounds. Just complete all of these. You have to do this, and then you will do the practice in the class. So that's all you learn about organic compounds, and we'll do more practice in class. Thank you.
There's